When it comes to complex numbers, there are only a few operations that we really need to be aware of. The first one is how to add and subtract complex numbers. How to add and subtract complex numbers, and I apologize for my handwriting right there. If we're looking at number 1 here, if I say 8 minus 5i plus 2 minus or plus I, what I'm going to do is I'm going to combine my like terms. So that's 8 plus 2, which is 10, negative 5i plus I, which is negative 4i. Pretty simple. You just combine like terms just like any other polynomial type expression. Same thing here. If I said 4 plus 7i minus 2 plus 3i, what I'm going to do is I'm going to go ahead and take my negative in. I get negative 2 minus 3i because I'm subtracting the whole thing. 4 minus 2 is 2. 7i minus 3i is positive 4i. Alright, here's where I really want you guys to focus. It's on multiplication using I. So prepare your tokens because Chucky is about to get serious. FOIL using I. So again, we multiply first, outer, inner, last exactly the same. 4 plus 2i times 3 minus 5i. I'm going to go first. That's 12. Outer is negative 20i. Inner is positive 6i. And then last is negative 10i squared. So we can go and combine our I, so that is negative 14i. And remember, I squared, and we'll even write this down at the top of our notes here, I squared, please remember, equals negative 1. So we've got negative 10i squared. This is a negative 1 here, so what I really have is, when all is said and done, positive 10. So 12 plus 10 is 22, positive 22. So I've got 22 minus 14i as my final answer. Example 2. If I say 8 plus 5i times 2 minus 3i, you can just FOIL it out. You get 16 minus 24i plus 10i minus 15i squared. So we get a total in the center of negative 14i. Please remember that I squared is negative 1. So we've got negative 1 times negative 15, positive 15, and 16 plus 15 is 31. Okay, let's do some more interesting multiplications using FOIL and I. We are going to multiply the conjugate of 4 plus I. Now, if you guys don't remember a conjugate, and this is problem number 4, a conjugate is the same terms and yet different signs. So when this happens, please remember that the inners and outer terms are going to be able to cancel, but we'll do the first couple multiplying the inners and the outers so that you know that they do. I've got 16 minus 4i plus 4i minus I squared. Well, the negative 4i and the positive 4i, they're gone. Negative I squared is negative 1, so it's positive 1. My number is 17. Now, bear in mind that unlike the other FOIL problems, we don't end up with like 17 plus 17i or any kind of complex number. It is just a number. Keep that in mind because we're going to use that skill in just a few seconds. If I say, next example, 6 minus 4i, its conjugate is going to be 6 plus 4i. So I've got 36 plus 24i minus 24i minus 16i squared. That's going to go away. I end up with positive 16. So now the hardest part of this problem is 36 plus 16. That's a 2, and that is a 5. So my answer is 52. All right, let's do an even more challenging conjugate. If I said rad 3 plus 2i, its conjugate would be rad 3 minus 2i. So let's go ahead and just multiply this out. I'm going to go ahead and bypass the inners and the outers on this one. So rad 3 times rad 3 is 3 minus 2i squared. Well, I squared is negative 1, so that is 3 plus 2, 5. Okay, let's do a couple more non-conjugate problems. Okay, next one is, I believe, is number 7. If I say 3 minus 4i quantity squared, please do not, under any circumstances, distribute the negative and make it 9 minus 16i squared. I won't allow it! Now I'm going to tighten up my belt buckle by 1 loop so I don't feel hunger pains. Anyway, the problem was 9 minus 7i squared. Okay, if we're going to do this problem here, we have to remember to expand the problem. And now I've got 81 minus 63i minus another 63i plus 49i squared. So this part is going to be easy. This is minus 49 right here because I squared is negative 1. So I've got 81 minus 49. All right, that is 32. So I got 32 minus 63 and 63. That would be 126i. All right, so please don't distribute the negative into that one. So let's get back onto the topic of conjugates. Remember, a conjugate is when we have the same terms but a different sign. So if I said 2 minus 3i and I asked you to identify the conjugate would be 2 plus 3i. If I said 8 minus 6i, it would be 8 plus 6i. The only way that they can really mess with you in the book is if they give you something like 3i. Well, it's important to think of 3i as part real, part imaginary, so would it make sense, I hope, if I said 3i is really 0 plus 3i? So if I was to ask you for the conjugate of that, it would be 0 minus 3i. Or, in other words, just negative 3i would be the conjugate of 3i. So, to give you guys a more clear example, it would be, if I asked you for the conjugate of 7i, it would be negative 7i. The conjugate of negative 34i would be positive 34i. All right? So why do we use conjugates? Well, we used conjugates in the last section to rationalize the denominator because we were not allowed to have radicals in the denominator. Same thing with imaginary numbers. You can't have imaginary numbers in the denominator, so what we do is we rationalize the denominators to get rid of the i's on bottom. So if I look at 2 plus 8i over 3i, I look at the conjugate, which is negative 3i. Multiply it in. Here I get negative 9 on bottom, I squared. Remember to distribute the top. This is negative 6i minus 24i squared. Let's go ahead and simplify this a little bit. I squared is negative 1, so I get positive 9 on bottom. I get negative 6i. And then I squared again is negative 1, so I get 6i plus 24. So I'm actually going to go and rearrange that to 24 minus 6i over 9. Now, all three of these numbers can divide into 3, so I'm going to go ahead and do that. So what I really have is 8 minus 2i over 3. Bit of a process for this problem. Question 2. Let's do 11 plus I over 2 minus I. Well, remember, the conjugate is going to be the denominator, but backwards. So 2 plus I is going to be my conjugate. So what I have here is my first and last multiplying. So I end up with 4 minus I squared. I'm going to go and FOIL this out. I get 22 plus, let's see, 11 plus 2 is 13I plus I squared. So let's go and figure this out. This is really negative 1, so 22 plus negative 1 is 21 plus 13I over I squared is negative 1, so 4 minus negative 1 is 5. Let's do one more. If I have, say, negative 3I over 5 plus 4I, again, conjugate is going to be 5 minus 4I on top and bottom. Remember, with conjugates, I only need to multiply the first and the last, so I really have 25 minus 16 I squared. I'm going to distribute this in. I get negative 15I plus 12I squared. So let's go ahead and simplify what we can. I've got negative 15I. This is negative 12 now over I squared. We'll turn this into positive 16. 25 plus 16 is going to get me 41. Okay, and that just about does it for this lesson. We'll see you in the next one. Whoops.